Hello, class. Today I'm gonna move to section 5.4, finding empirical probability. I also have a chapter 5 discussion for you guys to work on to compare between the theoretical probability and empirical probability. Basically, I'm not talking about the rule of the empirical rule because we learned about it before, but this is the empirical properties, right? So in order to find the empirical property, you actually have to do the real things. We use simulation to find empirical property. You wanna, for example, if you flip a coin to get like flip a coin 10 times, right? Let me write it out. So for example, flip a coin 10 times, right? And then find the empiricals probabilities to get tails. To get tails, right? So you're gonna go ahead and report all the time that you flip. So for example, the first one you have a tail, then after that you have like a head, and then hair, and then tail, and then head and tail, and then tail and head. How many are it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe one more hand, something like that, right? So so you know that you have how many case how many, so the probabilities of event E will be the frequency of that event divided by how many trials do you have. So the frequency of event is 1, 2, 3, 4, right? 4 times you have tails because you're looking for tails, and then you have totals trials you have was 10 times, right? And it's equal to 10, right? So this is gonna be 4 out of 10, which is 2 out of 5. Okay, so that is the way we find empirical probability. And we can go ahead and go on the next line now. Clean this up. Okay, so based on the observation of real life event, we can have empirical probability. For example, like baseball players batting average, and then a percentage of times a bus arrived late. I hope myself gonna take away this one because this is talking about average. I'm talking I mean average, like you should say like probability of something, or percentage of something better, because we are talking about that. So we're not talking about the average, the mean things yet. So I will put away that. That's examples. So for the percentage of time a bus arrives late, you can think about, okay, look at the bus, and you report like, you wait there for about like 1 hour, and you check like 10, yes, about 10, I think about 10 birds, if they if they arrive late or not. So let's note that late will be denoted by number 1, and not late denote by 0. So so we have the first burst arrive late, so we put a 1, right? And then the second burst come, not late, like arrive on time, so put 0, right? So then the third one could be on time. The fourth on is late, okay? And the fifth is on time. The sixth is late. The 7 late. The 8 on time. The 9 on time. The 10 on time. So you can have the percentage attempt, percent takes up time. A bus arrive late can be, can be similar with the probability, but you're gonna multiply by hundreds. So we have probability late will be frequency. Frequency divided by n. Frequency is 1, 2, 3, 4. 4 divided by 10. So that's going to be 0.4, right? And then you multiply by 100% to get the percentage. So that's going to be 40% that a bus arrived late. Okay. So that is the way we find empirical probabilities based on observation of real life events, right? So similar with the discussion that I in chapter 5 that I have assigned you. So go ahead and work on that, please. All right. So now I'm gonna move to the next slide. Okay. So sometime instead of the case that you observe easily, like a coin flipping, like 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 the example that we did was birds, something like that. But sometimes we can't find the data, because like the situation was too complex for us to find the empirical probability of a random events. So, for example, like if the weather was, was not really good for us to stay there and see it's easily, something like that, right? In that case, we can sometimes simulate the situation to generate the data needed to find the empirical probability. Okay, so basically, we have to, in this case, we have to generate data needed. Okay, so let's go ahead to designing simulations. So when thinking about how to carry out a simulations, look at several different methods to find an easier to carry out to carry out random action with the same probability. So so we can we can look at several different methods, like maybe go to another day that that has better weather, something like that, and or you can use technologies, something like that, to check with to check with the data for knowing the bus is is late or not. Also, like for example, the case when I want you to flip flip 2 coin, right? Say flip 2 coins, right? But you don't have 2 coins. What are you gonna do, right? You can go online and search for the link with the game flip 2 coin, right? And for that case, you can, you can have like 2 coin this on the website to flip. Okay, so that's also work. All right, so we move to the next one. And this is the 2 different valid method that can be used to simulate single flip of a coin. So okay, so for the first one, each digits will represent a flip of a coin. All right, and we list odd digits such as like 1, 3, 5, 7, 9 represent the head, and the event digits represent the tails. I mean the even is like 2, 4, 6, 8, 10, something like that, right? Or another way is only that this is 0 and 1 will represent a flip of the coin, and the other digits will be ignored. So let 0 represent the tail and 1 represent the head. So which method do you think is easier, right? I myself think that B could be the better one, because you can think about the case like if you flip like more than 10 times, what you want to represent for for the first case. If it's like the 11 times gonna be like a like the head. So are you gonna use 11? But in there they're gonna just keep from 1 to 9, or maybe if you decide that, so it's mean that you keep having until like until the big number and more, even more big. So I mean it's make my eyes can't easily recognize which one gonna be head, which one is gonna be tail as B. I mean the way in B there. The way in B, you can easily see how many 0 there, how many 1 there, and then you can you can count how many tails, how many heads you can have, something like that, right? So myself, it's going to be B as a valid method, valid method in this case. All right, so let's move to the next slide to talk about steps for a simulations. Okay, so we have 7 steps to do simulations. So the first one is identify the random actions, right, and the probability of successful outcome. So identify the random action and probability of success outcome. We determine how to simulate this random action. Could be technologies, random number tables. 3, determine the event you are interested in. Okay, so make sure that you need to know which event you are interested in, and then explain how you will simulate one trial, and then the 5th is carry out a trial, record whether or not the event of interest occur. right? You need to record it. And number 6 is repeat the trial many times, at least 100 times, because that will make a large number and going to be going to make your empirical probability similar with or approximately equal to the theoretical probabilities. And then the last one is use the data to find the empirical probabilities. All right. So let's we move to the next slide. Before doing that, keep in mind that in my discussion, I asked you guys to do 50 times. It's not I mean at many at hundreds, but you can have some ideas. Is that is that gonna be a better result when I have a larger number? Okay. So now I'm gonna move to the next examples. Okay. So now this is example 1, which is talking about simulation for P 3 heads when tossing a coin 3 times. So basically, I want to have the probability of 3 heads. Okay. So identify the random action and the probability of successful outcome. So random actions is the outcome of a single coin toss. So you know that probability to get ahead will be equal to 1/2 or 0.5. And then number 2, determine how to simulate this. How to simulate this random action. So it could be the technologies or random number. I use a random number tables. So let event this let even this is tails and odd this is head. Okay, so in this case we use even this is tails and odd this is head. And you can also do by 1 and 0. That's fine too. Okay. Okay, number 3 is determine the event you are interested in. Keep in mind that I'm interested in whether we can get 3 head in 3 toss. Right? 3 head in 3 toss. Right. So let's me move to the next step. Okay, so explain how you will simulate 1 trials. So we're gonna read up 3 digits from a row in the tables. 8 digits represent a toss. So record T for even numbers and H for odd number. Okay, so this is the way we do how to simulate 1 trials. And then carry out a trial, record whether or not the event of interest occur. So if 3 head occur in 3 toss, you can record as yes. Keep in mind that this is a case that we use 3 heads in 3 toss, right? So we do after 3 time toss, we can record yes or no, right? Step number 6 is repeat the trial many times. It should be at least hundreds, right? So we're gonna count the number of time your event occur. So the last step one means use the data to find the empirical probability as the number of S on the top and divide by total number of trials in here. So it could be about 100 trials and how many yes, so you check that. So The next things I want to teach you is about law of large number. So if an experiment with a random outcome is repeated a large number of times, the empirical probability of an event is likely to be close to the true probability. The larger the number of repetition. So keep in mind the sentence. The larger number of repetition, the closer together these probabilities are likely to be. So the true probability actually it's same as theoretical probability, right? So so as large as much as as larger as you can, the empirical probability will be closer to the true probability. Okay. So this is section 5.4, and we talk about empirical probability. Hopefully you did get some idea about that. Please go ahead and work on the discussion chapter 5. Let me know if you have questions, and see you in the next chapter.